Hi guys, in this tutorial I'm gonna solve question number 7, paper 43, June 2010. Two rectangular boxes A and B are identical size. The boxes are at rest on a rough horizontal floor with A on the top of B. Box A has mass 200 kilogram and box B has 250 kilogram. A horizontal force of magnitude P acts on B. I prefer to use extend direction of the force P like this. So this is the force P to come out from B. A horizontal force of magnitude P is applied to B. The boxes remains at rest if P less than or equal to 3150 and start to move if P more than 3150 Newton. Find the coefficient of friction between B and the floor. The coefficient of friction between the two boxes now is given 0.2, given that P more than 3150 and that no sliding takes place between the box, show that the acceleration is not greater than 2. Find the maximum possible value of P. First, I will divide this question into 3 parts. This is the first part, second part, and third part. I will divide it into 3 parts. The first part, when you act by force P, and the force P is, when we act by a force P, the system still not moving. So no motion. Because of what? Because the value of P less than or equal to the frictional force. So when it is about to move, so when it is a limiting equilibrium, so P is equal to frictional force. So now I'm talking about the particle B. When we're talking about B, so B and A together, P is equal to the frictional force. P, it's given the maximum value 3150. 3150. Frictional force is equal to mu r when it is about to move. So remove friction force and write mu r. But R is equal to the weight. R is equal to mg, but we are talking about both together. So you have to add mass of A and the mass of B. 3150 is equal to mu. R is mg. M is 200 plus 250 multiplied by G, which is 10. From this equation, you can calculate the value of mu, which is equal 3150 divided by 200 will be 4500. So the answer will be 0.7. This is mu, this is part 1. When we increase the value of P and the system move in this direction. Now look at particle A. Particle A, when you resolve the forces acting in A during the motion, the force of the frictional force which take the particle A to move with B. So the forces during the motion without slide B, without sliding of particle A. So when you resolve the force and write Newton's law for the particle A, all the forces in direction of motion, which is frictional force, minus all the forces in opposite direction, is equal to MA. I'm talking about particle A. The friction force is mu r is equal to mass times A. R is mg. I'm talking about particle A. You can remove mass together. It's given the coefficient of friction is 0.2. 0.2 times G is 10 is equal to A. So acceleration is equal to 2. It's given here in part 2, the coefficient of friction between the two boxes 0.2. When P becomes more than 3150 and no sliding takes place between the box, show that the acceleration is not greater than 2. Now, if you increase the value of P, so the acceleration increased, but in this case, the particle is sliding. This is why it's written here, no sliding takes place. No sliding takes place, no sliding. This is in case of moving with acceleration maximum value of 2. So I will use the maximum value of acceleration and back again to the particle B. Now, if we are talking about B, don't forget to take mass of A together. If we apply second law of Newton in this part, P minus frictional force is equal to MA. To get the maximum value of P, use the maximum value found in the previous part for acceleration. So the maximum value of P, friction force is mu R, is equal M times A, acceleration, which is 2. So P minus mu is 0.7, R is mg, where is M sum of both together, which is 200 and 250 multiplied by 10. Without calculating this value, you will get it 3150. Is equal to mass together will be 450. Accelerations to calculate this value, you will get the maximum value of P to move without sliding the particle A. So 2 times 490 is 900, plus when you move to the other side, as I told you, if you write 0.7 times 10 times 450, so the answer will be same as I told you, will be 3150. Move it to the other side, 3150, then add, you can get the maximum value of P, 900 plus 3150. So the answer is 4050 Newton. Just again, this kind of question divided it into 3 parts. The first part, when the system at rest or about to move, this means the forces acting to the right is equal forces acting to the left. So P is equal frictional force. From this equation, you can find the mu. When the system, when you increase the value of P becomes more than 3150, the system started to move, but no sliding for A. Now look at particle A, move under its friction. The contact force between A and B is equal to MA. From this equation, you will get the maximum value of acceleration, whereas both move together without sliding particle A. So in this case, if you move with acceleration 2 or not more than 2, he asked to find the maximum value of P, back again to both together B and A. Apply second law of Newton, all the forces acting in the direction of motion minus all the forces in opposite direction is equal to MA. So P minus frictional force equals MA, friction force is equal to mu R, R is equal to mg. mg, solve this equation, you can find the maximum value of P. That's it, thank you.